thoughts of like fear, it doesn't heal, or in time would thoughts like that ever creep in? Or
Visualization, I would do things like I would visualize like future games, like visualize myself in the World Cup, like what I'd be doing, where I'm walking out of these stadiums, like really being positive about the future and like, okay, I know this is there, but while I'm here in the dark, I might as well do something that will help serve me later. And so I would think about like the players I would play against. I'd think about like the stadiums that I'd be in.
that would feel like,
Yeah.
would thoughts of like fear
Hey friend, and welcome back to the channel. Today we're going to discuss an end-to-end machine learning project. at the bottom, and literally just do git clone and you put in the link. And that's how you can clone all the projects in your new VS Code page, or if you use Cursor or any other IDE, it should be roughly the same. So that's the first thing. So let me walk you through the data set. And this project is from Telco, and Telco is a telecom company, basically, and we want to analyze if their customers are going to churn. Basically, are they going to leave the company for whatever reason? So this data set has 7,000 customers, and it has roughly 20 features, which means columns. And what we want to predict is if they're going to churn or not, if they're going to leave or not, based on the features. We try to build a predictive model here. It's a classification model, a yes or no, based on the features. In a project like this, it's very important to identify what is the metric, the KPI that matters the most for the business. So when we think of classification, we have a few key metrics that we look into. There's the accuracy, there's the precision, there's the recall, there's the F1 score. So you need to understand which ones matter the most for your business. And in our case here, the thing that will harm the business the most is people leaving the business, the company. They unsubscribe or they just cancel the subscription. And that's the best metric for it is the recall. So that's something very important to understand. So first of all, we can go into Kaggle in here. I will, of course, share the link. in the description below, so you can just go and click it, and you go at the bottom here, and you have this button here to download. You just go click on it, and it will download the CSV file for you, and you just go and put it inside of your project so that you're able to work with it. So if you go to my GitHub, you see that the data is not in here. This is just for me to not put too many things and make super heavy GitHub. I just keep it locally. But you can do it. The data itself is not that big. Just download it and go and put it inside the folder. So if we go and look into briefly our code, let me just close here everything. Just want to show you briefly the structure that was used in our project here. So you see that if you do git clone, you're going to be able to bring all these things in here, and the data will live in a folder like this. Data. So you have the raw data, which is the one that will be downloaded from the Kaggle that I showed you, and then when we have a few other steps, like we're going to process it and everything, we're going to just include it in here. So this is where you're going to put your data set inside of the folder data, and inside of it, inside of row, that's what we're going to put it. And the rest, obviously, of the code, we're going to walk through it, but this is one of the structures that I use, and this one is just to have a nice structure of what's going to happen step by step. So I know where I have my notebooks, I know where I have all my Python scripts, I know what I have, for example, just some README to go and read and add some details about what's going on, so on and so forth. So for now, we're going to take things step by step. If I go back in here, I can briefly walk you through the tools that we're going to use, so that you have more of an idea what you're going to learn today and what you're going to play with today. So first, we're using Python to do this project. In my case, I use VS Code as the IDE that I use. You can use Cursor or you can use PyCharm. It depends on your preference. It shouldn't matter. We're going to use Great Expectations. This is just a Python library that is going to help us basically just do a quality check of our data. So when we receive a new stream of data, it needs to fit some business requirements, and that's something that a lot of people completely neglect in the tutorial. We're going to do it. I'm going to show you how we implement it. Remember, this will be a high-level video in terms of coding. I won't be coding live. I'm going to be explaining to you what's in there because it's a heavy project overall. We're going to do some modeling, and the machine learning model we chose is the XGBoost classifier. I've tried a few. I'll show you briefly, but that's the one that gave us the best performance overall. We're going to use Docker for building a container for our project. So what happens in most tutorials is you get people that do a project in their own machines and everything works. They have the libraries, everything installed, the Python version, and then when they try and share with other people, it completely breaks. And that's because there's a mismatch in the dependencies, libraries, and the setup. And Docker removes all this headache. When you take your setup of the project and everything within it and put it into a container, then anyone from anywhere, like yourself, you could literally take this and reproduce it without having any issues. So we're going to walk through that as well. We're going to do and use MLflow, and this is for tracking the experiments that we do in machine learning. So all the metrics, artifacts, everything will be stored for us. So for example, let's say you work within a team and you try 10 different machine learning models, or you try to fine-tune a few things, and you want to roll back to the one that worked the best 3 months ago. This is how we do it. You will find all the historical of it. We're going to use FastAPI to have an HTTPS endpoint, which means that our model will be exposed to the internet so that it's usable from the internet, and that's a very important step what we're going to deploy, because when you go to the cloud, you will need a way to be able to communicate with your model, and if it's not exposed to the internet, you can't work with it. So that's a very critical one. We're going to use FastAPI, which is the one used in production in most companies. We're going to use AWS. It's one of the most famous clouds. We're going to use AWS ECS, which is the Elastic Container Service, if I remember. And this one, we're going to use a serverless solution, which is called Fargate. And lastly, we're going to create a UI, a web UI with Radio in Python, just so that any user is able to plug in some numbers and get the machine learning model to work for them. So for me to give you a demonstration of why get the machine learning model to work for them. So for me to give you a demonstration of why it will look in the end, any user is able to plug in some numbers and get the machine learning model to work for them. So for me to give you a demonstration of why it will look in the end, here I created this UI with Radio, and this is exactly all the features that we have. And when it's deployed, if I just go and play around with all the values that we have in here, and then I just plug in and click on submit, we get the prediction not likely to churn or likely to churn. So this is like in real time, we're using the machine learning that we built model, and we're getting the output required. Obviously, in reality, you have a stream of data that comes every day, and this output will be generated automatically. But since we don't have that stream of data, we're working with the static data that we have, but we're going to do exactly the same steps as you would do in production. So let's take things a step at a time. And just so I remember, when you go here and you want to clone the repository, you can take the link in here. You can give this repository a star as well to support me and to support this kind of content, because I will be doing more of it, and it doesn't cost you anything. And then when you go on your VS Code, you just do, as we did earlier, you just do git clone, and you put in the URL, and that's what you should be able to clone it. But for those that want to start a project from scratch, I'll briefly show you the way I do it in a quick way. I just save some commands that help me start the project from scratch and create all the folder, the project structure, the environment, the requirements, and the libraries within just a few commands that I will show you right now. But this is not necessary if you clone the repository. It is not necessary. This is only necessary for your next project when you start it from scratch. You can use these commands for yourself. So what you would do, you create an empty folder, for example, on your desktop. You're going to put it into VS Code, like literally drag and drop to start a new session. Then you're just going to go to terminal. You're going to type this. It will create the whole structure for you. And then let me do a demonstration for you so you get an idea. So let's say I go and I create a folder. So I'll come to VS Code. I'll start a new project. Let's say I do here. I'll just drag and drop a new empty folder. So to create a new session for me, I just call it here's test. Let me zoom in here. I'll close this. I'll just go to the terminal at the bottom, and I will literally just copy paste the command that I showed you on my Notion. So it's this one. And I'll just press enter, and you see all the project structure was created for me within seconds. No need to create manually. Then we can go back here and look into what's next. So after the project structure, I'll just include a quick README. You can also do it programmatically from the command line as well, or you can just go and inside your project, just create readme.md, and here you type anything about the project. This is just show you if you're doing it from scratch. I won't spend too much time here. Then we're going to go and add requirements.txt, which is the one that will have all the libraries that you want to install. You can add them just by using this command that I did in here. Let me just run it here for you at the bottom. So we just did it here, and you'll create, as you can see here, our requirements.txt for us. You can add any libraries that you want, and in here we're going to create our Python environment. And this is very important. We have here, we specify which Python version we want, the name of the environment, and we're going to activate it and install all the dependencies. So if we do that, you can do it one at a time. But if you do that, you're going to end up creating a new environment, and you're going to activate the environment, and you're going to be creating and installing all your libraries in there. As you can see, we've installed all of them, and now we are inside the virtual environment. So this is just tips that I'm sharing with you here in case you want to be reproducing yourself and starting new projects. That's how I start them. But now we're going to jump into the project itself. So now that I showed you how to set up the environment and do everything, especially if you're doing the project from scratch. We're going to jump into the exploratory data analysis, and this is where you do most of the things that you would like to then modularize and deploy in the cloud and everything. So this is the phase where a lot of data scientists are good at modeling, or data analysts are good at visualizing, exploring, cleaning. They shine in. and myself as well. So with an explore and cleaning, they shine in, and myself as well. So what I do usually is that I would do the whole project, or most of it anyway, I will do it inside a notebook. And the reason why is because I can explore easier. I can open the data in here, I can clean it, I can get a better idea of what's going on. And then afterwards I will think, okay, how can I make this production ready? And I will try and split each and every task done. Loading the data, cleaning the data, building the features and all that kind of stuff. So here I included a basic about the data. So we just talk about what we do with this data. Task done. This production ready. Better idea. Explore inside a notebook. The whole project. So what I do usually is that I would do the whole project, or most of it anyway, I will do it inside a notebook. And the reason why is because I can explore easier. I can open the data in here, I can clean it, I can get a better idea of what's going on. And then afterwards I will think, okay, how can I make this production ready? And I will try and split each and every task done. Loading the data, cleaning the data, building the features and all that kind of stuff. So here I included a basic about the data. So we just talk about what we do with this data, what is the content and things like this, which is not, we already spoke about it. So what's interesting is to look into the data. So we here imported the libraries that needed, pandas to work with tables, SNS and matplotlib here, Seaborn and matplotlib to visualize basically. So we just bring the data, we just bring it into a data frame, and then we read it, just one row. And here the goal was to just look at what, let me run it. Here the goal was just to basically look at what the data looks like and what are the features that we have. So here we can see the data, the features that it has, we can see all the columns, and here in the end we can see the column churn. So initially before the processing, the column churn will have either a yes or no. And after doing the processing, we're going to turn things and encode things into numerical values, because in machine learning you will need to have your features, which are the columns that we have, numerical, so that they can be read and processed by the machine learning model, because it only understands numerical values and not categorical values that has letters in them and characters basically. So yeah, we're looking at the data sets, and then we're going to just basically try and explore it, try to see if there are not missing rows, for example, if there are any outliers, weird averages. That's like an exploration phase, I will call it. But basically here it's clear for us that the target is churn, and the other features are the ones that we're going to use to try and predict the target. If it's yes or no churn, we're going to use all the other features that we have there. And we can already see the payment method, how many they charge per month, how much they already spent, and all this kind of stuff. The contracts, what do they have, online security, the tenure, how long, etc. So we're going to look deeper into this. I'm going to skip this part. And what we're going to notice is, when you look at the data, is that we have some of the columns or the features that have two different values. For example, gender, here we have male or female. Dependence, we have yes or no. Multiple lines, we have 3 options. And most of them have 3 options. And the churn one has, the payment method has 4, and churn has only 2. So in a classification model where we have a few categories, there are different ways of approaching things. If it's a binary classification, it's a yes or no. It's usually very straightforward. We can turn them into 0 and 1. Nothing difficult about it. But if it's more than 2, there is the possibility of choosing another type of encoding that we're going to use. This is a multi-class encoding. And in this one, using a one-hot encoding is the best option, because we have more than 2 features, but we don't have too many either. So if we had more than 10 or something like this, we will need to look into something completely different again, because one-hot encoding will end up creating more columns. It's like a binary. Think of it as binary. If you have 3 categories, it will give them a numerical value of 001 or 010. So it will like create for each and every category a separate column. So you can imagine if you had 100 and you have 100 times that you need to do those binary new columns, you'll have just too many columns to deal with, which will make it very complex for the computation. So that's something to keep in mind. So when you do the encoding, if it's a binary encoding, you just do 0 and 1 like we did here. Yes or no will be 0, 1. Male, female will be 0 and 1. And you'll just literally just turn those into 0s and 1s, and that will help us for our machine learning model to just have the numerical values instead of textual and characters. And for those that have above 2, which means I have 3, 4, 5 categories. We use one hot encoding with this function here, dot get underscore dummies. And what it will create, as you can see, it will create more and more columns for us that have Boolean values, false, true, false, true. And that's why I'm telling you, if you had more than 10 categories, for example, it will become so big and so difficult to deal with. Then obviously we'll need a cleaning phase, and this one is for anything that was unusual that needs to be cleaned. And in our case, we're going to drop the customer ID column because it's kind of irrelevant to predict the churn. We could have removed others, but that one seemed to me from the start it's completely irrelevant, so just remove it. We're going to turn all the columns that were Boolean because all these that had true, false are Boolean. So we're going to turn them into 0 and 1, so false 0 and true 1. It's as simple as that. So that's all our columns that we're going to use are numerical, either integers or floats. That's very important. And then we're going to move into looking at the correlation. We're going to create a heat map to see the correlation to the churn. And let me zoom in a little bit more. And we're going to see here we have the positive correlation up until the negative correlation. So we can see here the positive correlation. We can see that there are two that kind of stood out. The fiber optic option for the internet, they correlate a lot with churn. For some reason, people in this data set anyway, people that have fiber optic are more likely to churn. And those that have a payment method of electronic check also are 30% likely to churn. And on the other hand, those that have contracts of 2 years, which is like a long contract, or they stay long with the company, are less likely to churn. And I added a few notes in here just saying that negative correlation or positive correlation, both are quite important. Because sometimes a high negative correlation says that when this is high, we are less likely to churn. So that's also something to optimize for. It's very important to know because if we had a set of 1,000 categories of 100, we'd want to only keep the ones that are relevant and not compute for 100, which are unnecessary. We look into this multi-collinearity in the classification problems when we suspect that some of the categories or the features that we have might be multi-collinear, which means that both of them basically give us the same information, which makes the model very redundant. And when we do this VIF, we look at this, and if the number is above 6, 7, 8, 10 maybe, there is a multi-collinearity. And we can see all these features here have a very high multi-collinearity. So there are a few options here to consider. We either drop some features, or we can do some regularization techniques, like there's L1 and L2, Ridge and Lasso to use. We can see them in here, I added notes. Or use a tree-based model, something like the decision tree or the XGBoost or the LightGBM, because usually they handle these scenarios really well. And in my case, that's what I did. I jumped into a tree-based model so that we can completely not focus too much on this and start modeling already. So here in modeling, we can see first that I'm looking at the column of churn, and what I easily notice here is that there is a class imbalance. We have 5,000 not churning and only 1,800 churning. So there's an imbalance, and in your data set, you have to do everything possible to get a data as balanced as possible, because if you don't balance it well, then what's going to happen is that your model will start predicting more of the value that appears the most, which is fair enough. And in our case, we'll just need to make sure that we make it more fair, and there is a way of doing it. We can just adjust the threshold. So when we do the model, when we adjust the threshold, we can adjust the how much one category is compared to the other. So that's one of the ways that you can do it. Obviously, there are other ways that you can resample and things like this, or maybe duplicate some of the churned ones to get a more balanced data set. But that takes time, and there's a lot of also validation that needs to be done there, and it needs to make sense. Otherwise, you'll just end up messing with your data. So we're going to use this threshold. So one thing that we need to focus on and talk about is what is the metric that we're going to work with. And the metric that we want to focus on as a business. So if I was in a telco company and I need to build this machine learning model, what is my main thing? What is the thing that I'm focused on is not losing clients, which means that we don't want the false negatives. And the false negatives, the one that focus on it the most and try to optimize, is the recall. So here, if we look, business context prediction is asymmetric in cost. So false negatives, you predict a customer will not churn, but they actually leave. You miss the chance to intervene and keep them. And this is the worst thing that we want to be able to avoid. We want to spot all the people that were going to churn and maybe give them an offer, give them a discount, make them stay. And this is what we're going to focus on in our project, is optimizing for recall. And obviously there are trade-offs. When you focus on recall, you end up losing precision. So that's something that needs to be discussed with stakeholders, and it's very important to keep that in mind. Because you're not building just for the notebook, you're building to benefit the business, and you don't want to harm the business with your model. So as I mentioned earlier, I've tested the random forest classifier. I've also tested the LightGBM classifier, and lastly, I tested the XGBoost. I don't want to walk through each one of them. That's not the purpose of the video. I ended up choosing the XGBoost. It was slightly better performance than LightGBM in terms of recall, and it was faster. So faster is something to consider when you're in production. You want to have things work fast and with less compute. XGBoost doesn't mean less compute, it just means in this case it was faster, and that's why I went for it. So we can see here, it ran the training time in 1 second, and the prediction time was like in no time, literally. Here we can see precision, recall, F1 score, and support. So it's very important to know that accuracy is not the only metric in classification, and accuracy, it's in many cases, it's just when the data is super balanced and when we don't really care about the precision or the recall that much, in terms of none of them really affects too much our client base or our results. In our case, we want to optimize when recall equals to 1, which means that we want to spot all the people that we're going to leave the company, that we're going to churn. And this is the metric that we want to spot. So we have here 81.8% that we're able to spot with our model. So here what we did next is that we tried to look, because we use the threshold 0.3, and this one is to try and unbalance the data. And here what I did is I just tested a few different thresholds just to see what is the recall, because that's what matters to me the most, based on what's the threshold. So here with different thresholds, 0.25, 0.3, we get different recalls, and also we can see precisions and F1 score, which is kind of mixed of both of them, which is a very important one when you want more of a balanced response. So here I can see that if I go for 0.25, I get a better recall, but the precision drops a lot. So I might just leave it like this. But this is obviously a business decision to discuss with the stakeholders. But in our case, I'm the person making the choices. So let's say I'll keep it 0.3. So I chose the XGBoost. It gives us a decent recall and it's faster to train. So that's great. One step that a lot of people kind of neglect as well is fine-tuning our hyperparameters. So XGBoost has all these parameters in it. And by choosing and finding the right parameters, we can very much enhance our model. And what we do here is we use a library called Optuna. It's a great one. And we can just give it like a range of things to experiment with. So for example, the estimator from 300 to 800, the learning rate from 001 to 02, and so on. For all this, it will try a variation of things. And then it will give us the one that gave the best results. So if we keep going in here, we can see we're going to optimize and we're going to do 30 trials. So it's basically going to try 30 times and it gives us the best one of them. And you can see here, if we take just the trial 0, we can see it gives us here the recall. It gives us what are the hyperparameters that was used for that exactly. And in the end, if we go down, it will give us here best parameter. Let me zoom in a little bit more. Best parameter, and it gives us this one. 300 estimators, this learning rate, this max depth, this, all of them basically. I don't want to walk you through all of them. And that one gives us the best result. And then what we're going to do is we're going to just bring those best parameters, instead of writing them ourselves manually, we're going to just bring this one, best parameter, and we're going to just do a random state of 42 so that when we rerun, we get the same thing. And then we're just going to time it to see how long it took and everything. So basically the same as we did before. And here we see that we improved to 92.8% looking at the recall equals to 1, meaning that the possibility of the client leaving the company, which is very important. Yes, we get a lower precision, but in our case, we said we're going to optimize for recall. And we see that we optimize from 81.8% to 92.8%. So it's 11.1% of people that we're going to churn that we kind of save with this model. Yes, we're going to target more people that weren't going to churn with our new campaigns, but we'd rather save those that were really going than just sending a few more emails to people that were going to stay in. So this tuned model here gave us 92.8% of recall, so it's the best. The precision is very low, so many loyal customers are being flagged, which means that we're going to end up contacting them thinking that they're going to leave, but they won't. And this is the in the classification metrics trade-off where you have an increase in recall but a drop in precision, and you always need to find that balance where it's acceptable. And in our case, we aim for a high recall, and we got a high recall for now. So now if we just wrap this notebook, and you can see what all we did, we explored the data, we loaded the data, we explored it, we did binary encoding for the categories that had 2 categories in them, and we did one-hot encoding for those that had 3 or 4 categories in them, like values. And then what we did is we cleaned the data, we turned the Boolean columns into numerical columns, we dropped them columns. Then we looked at the multicollinearity, but we found out a few features what we were highly multicollineated, and we decided to use a decision tree based or a tree based model like XGBoost. We tried a few machine learning models like Random Forest, LightGBM, XGBoost, and we decided to go for XGBoost. And then we fine-tuned the hyperparameter to boost our results. The experimentation here with MLflow, I left it for the next phase, and I'm going to show you how we're going to do it. So usually, if you did everything in here, this looks a lot like the tutorials I usually follow, and then you stop. And you're like, I've built a great model, I've got a great recall, I'm great. But no one can use this model. And therefore, that's why the importance of going through the pipeline, of going next to modularize everything we've done into Python scripts, and then adding MLflow for tracking machine learning models. Then we're going to use FastAPI to serve that model into the web, and then we're going to put that all into a container so that it's reproducible from anywhere. Then we're going to use GitHub Actions so that we're able to test, run, and push that container into the cloud, and in the end, use AWS so that we're able to deploy and also visualize with our radio UI and share it with anyone from the internet. So we're going to keep going step by step. The next phases will be less code-oriented, less technical. I will still go through them, but not in a very detailed way as we did now with the notebook, because with the notebook, you got the idea of all the steps. Now I'm going to show you how we split them and focus on the important modules as well. So let's do a quick recap of what we did initially. We just went through the environment setup, the library installation, the GitHub repository, and I showed you how to do it from scratch. You also need to go to GitHub and create your own repository. And I also showed you how to just clone it and bring the same project that I have in your environment. Then we walked through the exploration. And here we went through the problem, the data, we analyzed it, we built the model, we did hyperparameter tuning, and our conclusion is the model that we chose with those hyperparameters. And here, what we did, we focused on the recall, which is the business metric that we focused on. So I left all this information here. I didn't have to read too much through it because we built, and that's the best way to do things. The next phase will be to turn the notebook